Hi guys. I wanted to make this video going over all 30 questions that are on the study guide since I am not there today being November 1st. One big thing, Oliver won't stop barking, so we're just going to ignore when he barks, just not even going to bring it up. This is take number 6. And also, my tablet pen, I left at school. So we're going to have to do this old school style. We're going to roll with it, but I really want you to have this video, before you take the test. So here's question number 1. As you can see, there's a toy car that's going around in a circle. I'm going to assume that you've read all the questions. So because I know that Y represents distance and X represents time, I want to pick a graph that's going to show it going away from the wall and coming back and going away from the wall and coming back and going away from the wall and coming back. And there's only 2 graphs that really do that. This graph right here and this graph right here. I can eliminate B because distance can never be negative. Distance is just a positive thing. I can't be a negative distance away, but I can be a certain distance away in an opposite direction. However, distance is always positive, so we get rid of that. C, I don't even know what this is. It's not increasing its distance. It's going to eventually come back and meet the wall again. So eliminate C. Now we're going to go back to the roller coaster idea that we started out the year with. Roller coasters don't look pointy. They go up and down in a nice motion with changing rates of change. So I know that D is incorrect, and I know that it has to be A. All right. Clear all drawings. We're going to go down. We're going to look at this. A ball is thrown through an open window. What is the height of the ball in meters at time t, blah, 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 blah. This one is a little bit tricky. And this one I used Desmos. So I'm going to go to Desmos. You can use your graphing calculator, but that's a lot for me to pull up right now. So I'm just going to graph that function. It was negative 4.9 x squared plus 4.4x. Gosh, was it 15.25? 24. Okay. And now I just want to change it so that I can take a look at everything. I see that it reaches a maximum height of 16.228 and it hits the ground at 2.269. Here is where it's going to trick you. Those are 2 key points. We see the key point right here, and we see the key point right here in section D. However, you really need to read the full sentence. Then the height of the ball decreases until it reaches the ground 2.269 seconds after reaching its maximum height. So this is 2.29 seconds after it's hit the tippy top. Is that true? I don't know. But I do know that I can eliminate B and I can eliminate A just based on the fact that the maximum height is not 16.228. So let's go back and take a look at our graph. It reaches its maximum height at about 4.45 seconds. I'm sorry, 0.45 seconds. That is 2.269. So if I were to subtract them, 2.269, and then what did we say that one was? Minus 0.449. I think that's what it was. Yep. Then we just subtract. So it actually hits the ground 1.82 seconds after it reaches its maximum height. And where do we see that? right here at C. So the answer to that one is C. All right, 2 down, 28 to go. Let's take a look at this. The function g of x is given. Which interval is the rate of change the least? So remember, least doesn't necessarily mean the shortest. It could mean the steepest in a negative direction. Wink, wink. So let's just draw our tangent lines since it's giving us intervals to focus on. So from 3 to 2, I'm sorry, -3 to -2. If I were to make that line a little bit bigger, I guess I can't. We're going to try it again. Yeah, we can see that that tangent line has a positive slope. Let's just draw a whole bunch of tangent lines. From -1 to 0, that is a negative tangent line. Okay. 1 to 2, that's also negative. It's not as negative because it's not as steep. And then from 3 to 4, from 3 to 4, it's actually just straight across. Why aren't you drawing? What did I do? There we go. So I want to find the secant line. I've been saying tangent. It's actually secant. Secant is 2 points. Tangent is 1. I want to find the secant line that is the steepest in the negative direction. So I can eliminate 2 right now. I can eliminate A. I don't know what's happening, guys. I'm trying my best. I just want to be able to draw. Can I freehand? There we go. And I can also eliminate D since that is a 0 for the slope. So which one of these has the steeper negative slope? It is B. It's steeper in the negative direction, so therefore they would consider it the least. All right. This is the tangent line one. On the first day of which month is the rate of change the greatest? So I'm just going to draw my lines. February, drawing May, drawing August, and then drawing November. Which of these is the rate of change the greatest? Well, there's only one that is positive, and it's right here at May. That's it. We are going to continue. All right, these are going to get a little bit wordy, and that's okay. The function f is defined for all real values. The rate of change from a to a plus 1 is given by this expression. Ugh. So to go from a to a plus 1 is the same thing as going from like 2 to 3 or 3 to 4 or 4 to 5. Like that's all that means. And if it's increasing at 2a plus 1, I know that it's increasing at a constant rate. It's constant because it's just 2 times whatever plus 1. If it's increasing at a constant rate, I know that it is going to be concave. Sorry. Oh, this handwriting is not how I want it to be. Up. Remember concave up? That's our little cheat to remind us what concave up looks like. Average rate of change over the intervals is positive, so it could be a line with a positive slope. It could be a parabola that opens up. The rate of change is increasing at a constant rate, so it could be a line with a positive slope, increasing at a constant rate, so it could be a parabola that opens up. So my rate of change may not always be positive. It could be negative, as if I plugged in, say, a -4, that would give me -7. So it may not always be positive. But I do know that it's always increasing. And when the rate of change is increasing, it's going to be letter D. All right. Clear and move on. Number 6. Ooh, yuck. The function f is not explicitly given. The function h is g of x plus 1 minus g of x. If h of x equals -6, which of the following must be true? Yuck. Okay. So here's the big trick. G of x is giving information about f of x's rate. And h of x is giving information about g of x's rate. So if my rate is dropping -6 each time, I know that it's decreasing. And when my rate is decreasing, it's concave down. It's a little bit tricky, I know, very wordy, but you could always just eliminate. And since h of x told me about g of x, which told me about f of x, I know I'm only focused on f. So I can eliminate B, and I can eliminate A. And now you just have a definition about concavity. All right, moving on. Okay, for the polynomial function, the rate of change is increasing where x is less than 2 and decreasing for when x is greater than 2. Which of the following must be true? So my rate of change is increasing. So it's swooping up, and then now it's decreasing. So right here at x equals 2, there's a point of inflection. So it's either going to be C or D. I know it's not going to be B. I know it's not going to be A. It's concave down where x is less than 2 and concave up for x is greater than 2. Well, I thought concavity was about increasing and decreasing rates. If it's increasing, it'll be concave up at this interval, because that's the interval it gave you, and concave down at the other. So it has to be D. All right. Polynomial function is given by this. First things first, let's figure out our degree. And our degree is going to be the number of x's that we care about. So I have 1x here, and I have a multiplicity of 2 here. So 1 plus 2 gives me a degree of 3. So let's cancel that out. Let's cancel that out. The way that I get my standard form is by foiling all this out, okay? I don't feel like doing that. So I'm going to just take my leading terms and multiply them. My leading terms in this first factor is x, and my leading term in the second factor is 3x. However, we just said that that has a multiplicity of 2. So I need to do it twice. What do you know? That's going to give me 9x cubed. And that's my leading term. My leading coefficient's 9. My degree is 3. I know it's D. Let's move on. All right. Polynomial, the function q is polynomial degree 3 if q of 5 equals 0, which is true. All right, it's a cubic function. We know that because they said so. That's what degree 3 means. I also know that at 5, there's a 0. That's what that means. So it could be, you know, going like this, or doing something like this. Imagine across that. I really have no idea what the end behaviors are, so I don't know what's happening. But what I do know is that there is a 0 at 5. Can I confirm that the negative version of it's also a 0? No, I can't confirm that. It has 2 complex zeros, maybe, but I can't confirm that. It can be expressed as x minus 5 times p of x, where p of x is a polynomial degree of 2. That's really confusing, but let me break it down. So if I took a cubic function and split it into 2 sections, I'm either going to have an x squared and an x, or I'm going to have an x times an x squared. But either way, when I multiply these, that's the way that I can break it up. This is my degree of 1, which means the degree of the other part of my function has to be a degree of 2. But let's take a look at what this is. Q of x can be expressed as p of x divided by x minus 5, where p is a polynomial of degree 4. This is now a rational function, and we know that rational functions behave differently. So we are going to say it's c, because x times x squared gives me that cubic function. That's the only thing that I can confirm. Please clear it out. Okay. All right, I'm just going to do 10 questions at a time so I can upload the 3 videos and you can pinpoint exactly what you need. All right, the leading term of polynomial function a n x to the nth, where a n is a real number. Blech. Hey, just take a minute, okay? You got a number, a, you have x, and you're raising it to a degree that has a positive integer. That's what we know. We know we have an x minus 3, an x minus I, and an x minus 2 plus I. Here's the only thing you need to know. Remember, our complex zeros come in complex conjugate pairs. So he has to have a friend. He has to have a friend. So that's 2, 4. He's all by himself. So it's at least 5. It can't be 3 because I know that they have a pair. Can't be 4 because I know they have a pair. And then the least possible value of n would be 5. 5 is less than 6. That's why we pick 5. All right, I'm going to stop this here and do the next 10 in another video.